Hello everyone, welcome to the 6.3 and 6.4 video identifying parallelograms and rectangles. I just went ahead and combined these two sections together since they were pretty similar. So at the top of the notes here, I'm going to go over the conditions for parallelograms. And the first bullet point says that opposite sides need to be congruent and parallel, so like FG needs to be congruent and parallel to JH. FJ needs to be congruent and parallel to GH. And it says, if one pair is parallel and congruent, then both pairs are. So if I say, hey, these two are parallel and congruent, then you can gather that these two are parallel and congruent. What it says next is that opposite angles need to be congruent, so ignore the diagonal lines, like angle J would be congruent to angle G, and angle H would be congruent to angle F. And consecutive angles are supplementary. Consecutive angles would be F or J, like angle F plus angle J would add up to 180, or angle F plus angle G would add up to 180. You can go consecutive side to side or top to bottom. And then lastly, it says diagonal segments bisect each other, making congruent segments. So like JK would be congruent with KG, and FK would be congruent with KH. Okay, so knowing all that, you're going to prove that these collection of points make a parallelogram. And so we're going to prove it by using the slope or the distance formula. So you technically don't have to graph these. You could if you're, need to see the visual of it. But, as your teacher, the objective of this lesson is to be able to prove it using the slope and distance formulas. So, if it's a parallelogram, you're going to have two slopes. You're going to have a pair of slopes that are the same, and then you'll have a separate pair of slopes that are the same. And because, same slope makes parallel lines. So if you don't remember the slope formula, it is m equals y2 minus y1 over x2 minus x1. So the first thing I'm going to do is find the slope of AB. So the y2 minus y1 would be 2 minus 3 over the x2 minus x1 would be 3 minus negative 2. Don't forget to write your negative in parentheses if you're ever subtracting out a negative, because sometimes kids, they forget to do that and they only write one negative and they make a mistake. So anyway, this is going to equal 2 minus 3 is negative 1, and 3 minus negative 2 is positive 5. So it equals negative 1 over 5. If you want, you can rewrite that fraction with the negative on the side. It doesn't really matter, but sometimes people do that. So next I'll do the slope of BC. So the y2 would be negative 1 minus the y1 of 2. And the x2 would be positive 2 minus the x1 of positive 3. And so negative 1 minus 2 makes negative 3. And 2 minus 3 makes negative 1. And so that's going to simplify to get positive. The negatives would cancel. So positive 3 over 1 just makes positive 3. So next I'm going to do slope of CD. So y2 would be 0 minus y1 of negative 1. And then x2 would be negative 3 minus x1 of 2. And so 0 minus negative 1 is positive 1. And negative 3 minus negative 2 is negative 5. And see, the first one was negative 1 over 5. That's the exact same thing as 1 over negative 5. Because like I said before, you could just rewrite it with that negative on the side. And that way it doesn't confuse you. So we have two slopes that are the same, negative 1 and negative 5. Generally, that's good enough to say that this is a parallelogram once you have two matching slopes. Because at the top of the notes I mentioned that if you know that two of them are parallel and congruent, then the other two are parallel and congruent. But because it's notes, I'm going to find the slope of AD, and we're going to hope that it is 3. So for AD, I had to zoom out a little bit, but y2 would be 0 minus y1 of 3, and x2 of negative 3 over x1 minus x1 of negative 2. And so that gets me negative 3 over negative 1, which the two negatives cancel, giving me positive 3 over 1, which is also positive 3. So I have matching slopes, two pairs of matching slopes, so that's good. So this is enough data to say, yes, this is a parallelogram. So number 2, we're going to use the distance formula. And so if you don't remember the distance formula, I wrote it down right here. And so I'm going to do it, I guess the same kind of pattern. I'm going to go distance of DE, then EF, then FG, then DG. So let's start with DE. So x2 would be 2, x1 would be negative 1, so 2 minus negative 1, make sure you use parentheses, squared plus y2 minus y1, so that would be 4 minus 1, and then we're going to square that. And so you're welcome to type this into your calculator and get it to the nearest thousands place. That's usually what I ask my students for. If you're looking to simplify the radical, this makes 3 squared, this makes 3 squared, so that's 9 plus 9, that's square root of 18, which would simplify to 3 square root 2. But if you were to round that answer, you're going to get approximately 4.243. Next, let's get the distance of EF. I'm going to take the square root of 6 minus 2 squared, and then I'm going to add that to 4 minus 4 squared. And so 6 minus 2 is 4. 4 squared is 16, and 4 minus 4 is 0, so squaring that is 0. So what is the square root of 16? That will be 4. So next I'll do the distance of FG. So x2 would be 3 minus x1 is 6. And then I'll add that to 1 minus 4 squared. So 3 minus 6 is negative 3. Negative 3 squared is positive 9. 1 minus 4 is negative 3. And negative 3 squared is positive 9 again. So 9 plus 9 is 18, giving me the same as the first answer. Square root of 18 is the same thing as 3 square root 2, which is approximately 4.243. So this looks like it's going to be a yes because we have two that are the same. But let's just take the distance of D to G and check to make sure that it's also a 4. So for the x's, I'm going to do 3 minus negative 1 squared. And I'm going to add that to 1 minus 1 squared. So 3 minus negative 1 is the same thing as 3 plus 1. That's 4. 4 squared is 16. And 1 minus 1 is 0. So the square root of 16 is 4. So everything checks out, making this also a parallelogram. So the next part to go over on the notes is the conditions for the rectangles. And basically all the conditions for parallelograms apply to rectangles, except rectangles have a couple of, a rectangle is a specific type of parallelogram, in that all of the angles are right angles. Okay, so in other parallelograms they can be any angle. And so you got to remember that the intersecting sides like AD and DC, they are perpendicular. So when you're doing your slope formula, you need to have opposite reciprocal slopes so that you can verify that they're making a right angle at the point of intersection. These other things are still the same. Opposite sides are parallel and congruent. And then the diagonal segments bisect each other, making congruent segments. So the diagonals like BD and AC will be congruent. So that actually makes a little less work for us to do on the distance formula. And I'll show you what I mean when we get there. But first, let's do this slope formula. And again, we're going to look for opposite reciprocal slopes. So doing the slope of AB, I have y2 of 3 over minus y1 of 0 over negative 2x2 minus an x1 of negative 3. So 3 minus 0 is 3. Negative 2 minus negative 3 is negative 2 plus 3. So that makes 1. So I have a slope of 3 over 1, or just 3. Next, I'll want to do the slope of B to C. So I have y2 of 1 minus y1 of 3 over x2 of 4 minus x1 of negative 2. So 1 minus 3 is negative 2. 4 minus negative 2 is 6. So negative 2 over 6 simplifies to negative 1 over 3. So for my slope of CD, I'm going to do negative 2 minus 1 over 3 minus 4. And so that's going to give me negative 3 on top and negative 1 on bottom. That simplifies to get positive 3 over 1, or just 3. Once you've done those three slopes, you're going to do the slope of A to D. And so y2 minus y1 would be negative 2 minus 0 over x2 minus x1, 3 minus negative 3. And so negative 2 minus 0 is negative 2. 3 minus negative 3 is 3 plus 3, so that's 6. And negative 2 over 6 simplifies to get negative 1 over 3. So we have two pairs of matching slopes. Are they opposite reciprocal slopes? Yes, they are. 3 and negative 1/3. That's, you flipped it and then you changed the sign. So yes, these are opposite reciprocal slopes. So these lines intersect perpendicularly, making right angles, forming a rectangle. Rectangle, I just wrote this note right now. If you're trying to prove a rectangle, then just take the distance of the diagonals. So you know something's a diagonal when you just skip over a letter. So do distance of A to C and distance of B to D. And they need to be the same distance in order to be a rectangle. If your diagonals are different distances, then it still might be a parallelogram. You'd have to go back and do the distances of the sides of the parallelogram to see if it's a parallelogram after that. But it would doing the distance of the diagonals definitely proves whether it's a rectangle or not. So my distance of AC, x2 minus x1 would be 3 minus negative 3 squared, plus y2 minus y1, 3 minus 1 squared. 3 minus negative 3 is 3 plus 3, that's 6. 6 squared is 36. And 3 minus 1 is 2. 2 squared is 4. So this is the square root of 40. Simplifies to get 2 square root 10 if you're trying to simplify the square root. And if you want to get the decimal, then I'm going to round it to the nearest thousandths place again, giving me approximately 6.325. So I'm going to calculate the next diagonal from B to D, and I want to see this value as well. So for my x2 minus x1, I'll do 3 minus negative 3. And my y2 minus y1, I'll do 1 minus 3. So 3 minus negative 3 is 3 plus 3, that's 6. 6 squared is 36. And 1 minus 3 is negative 2. And negative 2 squared gets you positive 4. So just like the one before it, you have positive 36 plus positive 4, giving you a square root of 40. So we do have the same number, giving me a simplified radical of 2 square root 10, which rounds again to the nearest thousandths place as 6.325. So that's going to wrap it up for these notes. Thank you for watching, and goodbye.